So hey guys, welcome again to my vlog. So today we discuss the OSI TCP model, encapsulation and decapsulation and the others. So let's start. The Open System Interconnection Model is a OSI model is a conceptual model that characteristic and standards the communication function of a telecommunication or computing system without regards to the underlying internal structure and technology. Its goal is the interoperability of diverse communication systems with standard communication protocols. The model partitions a communication systems into abstraction layer. The original version of the model had 7 layers. A layer serves the layer above it and served by the layer below it. For example, a layer that provides error-free connection across the network provides the path needed by application above it, while it calls the next lower layer to send and receive packets that constitute the context of the path. Two instances of the same layer are visualized as connected by a horizontal connection in that layer. The model is a product of the Open Systems Interconnection Project at the International Organization for Standardization or ISO. So TCP IP model, prerequisite layer of the OSI model. The OSI model, we just look at it just as a reference logical model. It was designed to describe the function of the communication system by dividing the communication procedures into smaller and simpler components. But when we talk about the TCP of the IP models, it was designed and developed by Department of the Defense or DoD in 1960s and is based on the standard protocol. It stands for Transmission Control Protocol or the Internet Protocol. The TCP IP model is a concise version of the OSI model. It contains 4 layers, unlike 7 layers in the OSI model. Their layers are process application layer, host-to-host or a transport layer, internet layer, and network access link layer. So the first is network access layer. So what is that? This layer corresponds to the combination of data link layer and physical layer of the OSI model. It looks out for the hardware addressing and the protocols present in this layer, allows for a physical transmission of data. We just talked about ARP being a protocol of internet layer, but there it is conflict about declaring it is a protocol of the internet layer of network access layer. It is described residing in 3 layer and being encapsulated by layer 2 of the protocol. So internet layer. This layer parallels the function of the OSI network layer. It defines the network which are responsible for logical transmission of data over the entire network. The main protocols residing at this layer are IP. IP stands for the Internet Protocol and it is responsible for delivering packets from the source host to the destination host by looking at the IP addresses in the packet header. IP has 2 versions, IPv4 and IPv6. IPv4 is the one of the most of the websites are using currently, but IPv6 is growing as the number of IPv4 addresses are limited in the number when compared to the number of users. ICMP stands for Internet Control Message Protocol. It is encapsulated within IP datagram and it is responsible for providing hosts with information about network problems. ARP stands for the Address Resolution Protocol. Its job is to find the hardware address of the host from a known IP address. ARP has several types: reverse ARP, proxy ARP, gratuitous ARP, and inverse ARP. So next is the host-to-host layer. This layer is analogous to the transport layer of the OSI model. It is responsible for end-to-end communication and error-free delivery of data. It shields the upper layer application from the complexities of data The two main protocols present in this layer are Transmission Control Protocol or TCP. It is known to provide reliable and error-free communication between end systems. It performs sequencing and segmentation of data. It also has acknowledgement features and controls the flow of the data through flow control mechanism. It is a very effective protocol but has a lot of overhead due to such as features increased overhead leads to increased cost. User Datagram Protocol or UDP. On the other hand, does not provide any such features. It is the go-to protocol if your application does not require reliable transport at it is very cost-effective, unlike TCP, which is connection-oriented protocol. UDP is connectionless. Number 4 is process layer. The layer performs the function of the top 3 layers of the OSI model: application, presentation, and sessions layer. It is responsible for the node-to-node communication and control user interface specifications. Some of the protocols present in this layer are HTTP, HTTPS, FTP, TFTP, Telnet, SSH, SMTP, SNMP, NTP, DNS, DHCP, NFS, and X-Window, and the LPD. So have a look at protocols in application layer for some information about this protocol. Protocol other than those present in the link articles are HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol. It is used by the World Wide Web to manage the communication between web browser and servers. HTTPS stands for HTTP Secure. It is a combination of HTTP and SSL. It is efficient in cases where the browser needs to fill out forms, sign in, authenticate, and carry out the blank transactions. SSH stands for Secure Shell. So it is the terminal emulation software similar to Telnet. The reason SSH is the more preferred is because of its ability to maintain the encrypted connection. It sets up a secure session over a TCP or IP connection. NTP. NTP stands for Network Time Protocol. It is used to synchronize the clock on our computer to one standard time source. It is very useful in situations like bank transaction. Assume the following situation without the presence of NTP. Suppose you carry out a transaction where your computer reads the time at 2:30 p.m. while the server records it at 2:28 p.m. The server can crash very badly if it is out of the sync. The term encapsulation is used to describe a process of adding header and the trailer around some data. This process can be explained with the 4-layer TCP IP model, with each step describing the role of the layer. For example, here is what happens when you send an email using a favorite email program. The email is sent from the application layer to the transport layer. The transport layer encapsulates the data and adds its own header with its own information, such as which port will be used, the process, and the data of the internet layer. The internet layer encapsulates the received data and adds its own header, usually with information about the source and destination IP addresses. The internet layer then passes the data to the network access layer. The network access layer is also only layer that adds both header and the trailer. The data is then sent through a physical network link. Frame. Frame is encapsulated data defined by the network access layer. A frame can have both a header and trailer. Packet. Encapsulated data defined by the network layer. A header contains the source and destination IP addresses. Segment. Segment is encapsulated data as defined by the transport layer. Information such as the source and destination, ports and sequence acknowledgement numbers are included in the header. Data encapsulation in the OSI model. Just like the TCP IP layers, each OSI layer asks for services from the next lower layer. The lower layer encapsulates the higher layers, the data between in a header. So, while the TCP or IP models use term like segment, packets, and frame to reverse data define a particular layer, the OSI model uses a different term, protocol data unit or PDU, and PDU or protocol data unit represent a unit of data with header and trailer for the particular layer, as well as the encapsulated data. Since the OSI model has 7 layers, PDUs are numbered from 1 to 7, with the physical layer being the first one. For example, the term layer 3, PDU refers to the data encapsulated at the network layer of the OSI model. So, in networking model, the terms encapsulation and decapsulation refers to a process in the which protocol information is added to the data and removed from the data when it passes through the layers. Protocol information can be added from the before and after the data. If information is added before the data, it is known as a header. If the information is added after the data, it is known as a trailer. So that's all for the OSI, TCP, IP models, encapsulation, decapsulation, and the others. So that's all for that vlog, and I hope you learned something from my vlog. So thank you for watching and listening. That's all. Thank you. Bye.